Liftoff.
JWST, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself.
Our universe is enormous and unique, and with each passing day, humanity advances in its exploration of the space around us. Exploration of space has been considerably easier since the development of space technologies such as the James Webb Space Telescope, designed by the United States National Aeronautics and Space Administration, NASA. The James Webb Space Telescope has proven to be a marvelous innovation, changing cosmologists' viewpoints and the way they view the solar system and its completeness. However, it appears that James Webb is capable of demonstrating some unusual phenomena right here in the heart of our own galaxy. The James Webb Telescope just detected a massive structure near the center of the Milky Way galaxy, according to experts. What exactly is this massive structure? What impact will it have on cosmological research as we know it? Stay with us until the end to know all the details about this latest shocking revelation. Since its launch in December 2021, NASA's James Webb Space Telescope has performed admirably. It is still the most modern and powerful telescope available, incorporating cutting-edge technology such as near-infrared camera, among other things. The first scientific photographs provided by James Webb in July captured the essence of some of the most undiscovered portions of faraway galaxies. More detailed pictures of the Carina Nebula, the Southern Ring Nebula, and an older clump of galaxies known as Stephan's Quintet were among the prominent photos. Light from some of these galaxies has taken billions of years to reach us, indicating that we are seeing the early phases of the birth of these galaxies and stars. While imaging distant stars is stunning, it appears that James Webb will be used to examine one of the universe's oddest phenomena: black holes. Black holes aren't just a bizarre cosmic occurrence. They're one of the universe's most powerful forces. These individual portions of space, unlike stars and galaxies, cannot be imagined because they have such a strong gravitational pull that even light cannot escape its dark abyss. However, light can still remain and form patterns around these gravitational giants, generating a picture negative confirming the presence of these gigantic cosmic giants. An international team of academics and scientists set out to acquire the first image of a black hole, focusing on Sagittarius A, the supermassive black hole at the center of our Milky Way galaxy. The image of Sagittarius A was nearly challenging to acquire, necessitating the collaboration of several observatories and radio telescopes all around the world. This global network of radio telescopes was known as the Event Horizon Telescope, and the procedure of capturing a single image of Sagittarius A was quite spectacular. This network of radio telescopes worked as a single unit, resulting in the largest planet-sized telescope ever operated. From observatories in Spain to another in the French Alps and all the way to MIT in the United States, a network of 10 observatories worked together concurrently. The antennas from these observatories required to be synced down to the millisecond. Thus, atomic clocks were set at each station to begin the procedure at the same time. The antennas and observatories used to capture the image of Sagittarius A had to observe in radio wavelengths for one major reason. Sagittarius A is located right in the center of the Milky Way galaxy, surrounded by a thick haze of interstellar gas and dust that absorbs light at an optical wavelength. As a result, seeing the black hole using a standard infrared telescope that views at optical wavelengths would have been impossible. After settling at the antenna, astronomers target the Event Horizon Telescope and Sagittarius A, which are approximately 27,000 light-years distant from Earth, cutting through a sea of stars, planets, and cosmic dust. The collected data was integrated and processed using advanced mathematical methods to reproduce the captured image. The reconstructed image depicted Sagittarius A's very first vision, which took the appearance of a blazing donut-shaped ring of light. This ring image is not of the black hole itself, but rather the outline of light outside the event horizon, which is just beyond the barrier where light cannot escape the supermassive black hole's gravity. The dazzling yellow ring that surrounds the black hole is a white-hot plasma with a temperature of more than 18 billion degrees Fahrenheit. Scientists were also able to establish that the supermassive black hole was approximately 4 million solar masses, which means it was approximately 4 million times the mass of the Sun, using the dimensions of the ring surrounding Sagittarius A. It also suggested that Sagittarius A was extremely compact and dense, with an apparent size that could fit within Venus's orbit. This image of Sagittarius A was the very first visual confirmation that the supermassive black hole at the heart of our galaxy did in fact exist, at a time when scientists were beginning to doubt its existence. The image demonstrated that their expected dimensions based on Einstein's theory of general relativity were correct, and that the black holes obeyed the most fundamental principles of quantum physics despite their enormous gravitational attraction. While the photos of Sagittarius A answered prior concerns about the state of our galaxy's center, they also raised an even bigger issue as scientists uncovered something really unexpected while examining that region of space. The Milky Way galaxy turned out to be stranger than astronomers had imagined, and the finding of an invisible barrier around the center of the Milky Way galaxy has sparked even more doubts about our galaxy's existing state. A team of Chinese Academy of Science researchers became interested in the movement of cosmic rays in and around the center of our galaxy and made a remarkable discovery. The researchers looked at a series of maps that depict the migration of radioactive gamma rays as they explode through and around the center of our galaxy. Gamma rays are the highest energy forms of light in the universe and can be produced when incredibly fast particles known as cosmic rays collide with regular matter particles. The map shows that something towards the heart of the Milky Way galaxy appeared to be impeding the flow of these particles and accelerating them to speeds approaching the speed of light. These accelerated particles are now generating a plethora of cosmic rays and gamma rays just outside the Milky Way galaxy's core. Furthermore, the study indicated that while the galactic center appears to be constantly sending a storm of high-intensity radiation into interstellar space, something near the galactic core appears to be blocking other waves of cosmic rays from accessing that region of space. This appearance, according to the researchers, is caused by an unseen barrier that appears to be bent around our galactic core and actively prevents a density of cosmic rays from entering the region. This invisible barrier also appears to keep the concentration of cosmic rays inside the core much lower than that found elsewhere in interstellar space. The study discovered that cosmic rays appear to be able to escape the galactic core, but this unseen barrier makes it extremely difficult for cosmic rays to enter the region. The center of our galaxy is located in the constellation Sagittarius, around 26,000 to 27,000 light-years from Earth. This region of space is extremely thick and dusty, with somewhat more than 1 million times the number of stars per light-year as the entire solar system. These stars and dust particles are all encircling a supermassive black hole that is the glue that ties the Milky Way galaxy together. Scientists suspected Sagittarius A or another undiscovered cosmic object at the galaxy's core had been accelerating electrons and protons near the speed of light. This activity has resulted in cosmic rays emitted through the Milky Way galaxy and beyond into intergalactic space. These cosmic rays are constantly streaming across our galaxy's magnetic field, forming an invisible liquid of high-density particles with fairly uniform density across the entire Milky Way. The cosmic ray C is the name given to this continual influx of particles. A group of scientists compared the density of cosmic rays at the galactic center to the density of cosmic rays in the cosmic ray C. Cosmic rays are invisible to infrared telescopes, but scientists can map them out using gamma-ray maps of space, which show regions of space where cosmic rays smash with other types of matter. Using this comparison, scientists deduced that something was not only accelerating cosmic ray particles and firing them into space, but was also actively blocking other such particles from entering the galactic core. Initially, the scientists assumed that the likely source was the supermassive black hole Sagittarius A. This is due to the fact that black holes can hypothetically accelerate and send particles out into space while appearing to devour everything else in the event horizon. Scientists discovered supernova remnants and strong stellar winds that originated in the early stages of the cosmos jammed at the center of the galaxy because they were unable to shoot out into intergalactic space due to this invisible barrier. However, the notion that Sagittarius A was responsible for the barrier was dismissed. This is because the gamma-ray image revealed a clear location where the concentration of cosmic rays appears to diminish dramatically at the galactic center's outskirts. This would be in stark contrast to how supermassive black holes function, as there would be a steady fall in cosmic ray density rather than a sharp drop if a black hole were producing this barrier. Another possible explanation for the barrier is stellar winds caused by the massive concentration of stars pushing against incoming cosmic rays, forming the apparent barrier in the same way as solar winds push against the cosmic rays to create the heliosphere that surrounds our solar system. This is the most likely explanation, since the heliosphere that surrounds our solar system also functions as a barrier, keeping the density of cosmic rays within the solar system much lower than the density just outside the barrier, as measured by Voyager 1. Scientists have noted that additional research would be required to better understand how and why this invisible barrier exists in the center of our galaxy, and that they would require the assistance of the James Webb Telescope to accomplish this. The James Webb Telescope has been targeted and designed to observe the behavior of Sagittarius A, which has proven challenging to investigate with previous lesser telescopes. In partnership with the New Horizon telescope, James Webb will try to comprehend the flickering impacts of Sagittarius A, which appears to flare up on an hourly basis, making imaging extremely challenging. This is mostly due to the fact that, despite being far further away than other observed black holes, Sagittarius A exhibits flickering flares caused by charged particles accelerating around the supermassive black hole, growing to higher energy levels and emitting light. James Webb will observe the Sagittarius constellation from space using its multiple, very advanced instruments, or the New Horizon telescope will join its endeavor on the ground. Together, the two telescopes will observe, reproduce, and understand not only superior footage of Sagittarius A, but also strange and peculiar phenomena such as the invisible barrier that surrounds that region of space. Now let's hear your thoughts in the comments down below.